All right, please let me know if you are able to view the screen. Okay, all right. So yesterday we started off with strings, right? And we saw that strings are nothing but essentially characters that are, or sequence of characters that are enclosed within single quotes or double quotes. That is what we had seen. And now we'll continue with some of the operations that we did. We'll just try to recap and then we'll move ahead. So string, as we know, are basically characters that are enclosed in single quotes or double quotes or also triple quotes. That is what we have seen. And for triple quotes, it was basically multi-line. And string are essentially sequences of text. That is what alternatively can be said of strings. So with respect to strings, we had learned yesterday that they are immutable in nature. We cannot, change the values or the characters that are there in the string, which is enclosed in single quotes or double quotes. In order to use some of the operations, we import string in this fashion, import string, and then using a dot operator, we take a particular property of it and then try to call upon string and then see what are the various characters that are available. So we do import space string and then string dot ASCII underscore letters will give us all the alphabets in the English language, and they are both lowercase and uppercase, right? They are a continuous sequence starting with the lowercase until Z, and then we have a capital A or the A with uppercase and then until Z. So these are the various letters that are generated when we use ASCII underscore letters, right? That is what we see here. So when we import string, right, we are trying to get the properties that are associated with string, and this is there in the standard library, right, which is basically coming from Python itself. So string dot ASCII underscore lowercase will give us all the alphabets that are in lowercase, starting from A to Z. 26 sequences of characters are provided, and they are enclosed in single quotes or double quotes. Depending on how we want to kind of view that data, we'll be able to use that. So string dot ASCII underscore lowercase gives us alphabets, 26 alphabets from the English language. And they are basically in the lowercase. Similarly, string dot ASCII underscore uppercase will give us the uppercase letters that are there. And this is again 26 in number. So A to Z is what we get, and they are in uppercase. String dot digits, right, gives us the sequence of numbers starting from 0 and ending at 9. Right, and this is a string representation, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are continuous. There is no space in between. And then this is enclosed in single quotes. That is the output that we get when we do string dot digits, right? And when we use string dot hex digits, all the digits that are there in the hexadecimal representation are printed out, right? String dot hex digits gives us numbers starting from 0 and ending at capital F. That is what it gives us. So this is a hexadecimal representation of numbers. In the hexadecimal system, we have 16 numbers, and those are represented starting from 0 and ending at F. Right? That is what we get here. Now, the reason why they put A, B, C, D, E, F in capitalized case is that also sometimes that is also there. That is also would be printed out to the output. So string dot hex digits is also something that we get as the output in either capitalized letters or in lowercase letters. Then we have string dot oct digits. Oct digits gives us the representation in octal format, right? That is what it gives us. So, and if you want to see what are the various digits in the octal format, we get the values as 0, starting from 0 and ending at 7. That is the octal digit, octal representation or the octal system. So there are 8 digits. In hexadecimal, there are 16 digits, and in the base 10, there are 10 digits, right? And string dot punctuation is something that we had discussed yesterday. And the string dot punctuation, we said it could be used especially when it comes to removing certain characters that are not needed from a string. That is one use case. Or if you want to see if a particular punctuation is available, right? And we want to check if it is available. So Python provides this particular operation, which gives us this output, and we can check if a particular punctuation mark is available or not. That is also something that we can do, right? So let's say we want to find out a particular character is available. Let's say it is a pipe symbol, and probably we can use this particular string dot punctuation operation in order to check that. How to check that or how the operator is being used? As we go further, we'll look at when we come across the operators, right? There are membership operators that we will go over, and there we'll see how to check for a particular character is present in a string value, or a particular character is present in some other representation, maybe an object or maybe a value. That is what we will try to look at as we go further. Right, so strings, we discussed that can be represented in single quotes or double quotes or triple quotes. Single quote representation is given like this. We have a variable text underscore s underscore quote is equals to 2t con has two words, 2t and con. This is what we started off yesterday. And this particular sequence of characters or sequence of text, which is basically a sentence, is enclosed in a single quote, right? That is what we have. Or this phrase is enclosed in a single quote. The same thing can be done in a double quote. So text underscore d underscore quote is equals to double quote open, and then the 2t con has two words, 2t and con, and then the double quote closed, right? This is how we kind of enclose the phrase or the sentence or the sequence of text in double quotes. And in order to view the output, the last line is supposed to be provided with the variable name. And then that is what would be printed out. So text underscore d underscore quote is what is printed out, and that is what we see as the output. So tutti con has two words, tutti and con. That is what we have. And for triple quotes or for 3 lines or multiple lines, right? So not 3 lines, for multiple lines, the same phrase that we use can be expressed in 3 lines, right? So text underscore tr underscore quote is what we are using as a variable name to represent the data that is represented in multi-line format using this triple quotes is equals to triple quotes open, and then we have the multi-lines string value, and then the triple quote closed, right? This is one use of triple quotes. There is another use of triple quotes where we can use for commenting. We had seen hash as one way of commenting, but this triple quotes is generally used in documentation, or we want to explain something better. Then also it could be used probably when we get into some other topic. I'll also demonstrate how this could be used for commenting as well. Okay, one application of it is basically representing string values. The other application is basically representing it in multi-line format for comments. That is what we could use this triple quotes as. Okay, so we'll try to come across when we move forward with other topics, then we'll come across that application as well. So we try to see this output by putting the line or the variable in the last line, and then we see that the output is basically tutti con has two word, tutti and con. All of these are represented multi-lines. How do we know they are multi-lines? Because there is a backslash n, which is also called as carriage return. That is what we have, right? It is basically a new line that indicates that is basically printed in a single line here, but it actually means that there are multiple lines for this output, right? That is what we have seen there. The other thing that we started off yesterday was understanding that the sequence of text is also indexed based, right? What do we mean by indexed based? Let's say we have this sequence, Prabhas, P-R-B-H-A-S, right? These are 6 letters that are there in this word Prabhas. So what we understand with respect to string is that we can actually get parts of what is there in Prabhas, or in fact, any string value that we may have using what is called as indexing. What is an index? Okay, in generally for storage, right? We have seen one thing with respect to a variable is that it is stored in some memory location, and that location is indexed by some number or address. That is what we have seen. Similarly, for string, if we want to know what is the order in which P is occurring in this particular string, we can use 0 as its value. right? 0 as its value to know where it is occurring. It is the first place it is occurring. So generally, in computers, we see whenever it is strings or it could be some other complex storages, the index starts from 0 majority of the times, and there are other programming languages where the index doesn't start with 0, but here it starts with 0, right? So P index is starting from 0. R index is starting from 1. Oh, sorry, or the index of R, it is not starting from 1. Or the index of R is 1. B is 2. H is 3. A is 4. S is 5. So for string, there is index that is assigned, right? P0, R1, B2, H3, A4, and S5. So if you have a bigger string, let's say we have something like Tudicon has two words, Tudi and con, right? Tudicon has two words, Tudi and con. So this T that we have, this is basically 0, U is 1, T is 2, so on and so forth, till 36, right? If we count the total indices that are available, there are about 36 indices for this particular string. But then let's say I want only a part of this particular entire string. I just want to know till the 5th index, what is the value, right? So how do we extract certain parts of it, or what we generally refer to this small parts are called as substrings? How do we extract that? Is basically using index, and this extraction of certain parts or certain substrings from a string is called as slicing. Okay, especially in Python, because we are using indexing. Indexing is used using this colon operator. Now, even before we begin with this, let's say we have text data like this, right? This is what we have, and I execute this. Okay, and I just want to know what is there at index 0, right? It says T is available, right? Similarly, if we try to do something like this, text underscore data, and then 1 is provided. Oops, sorry, I think underscore is not there. So if I do this, then you get U as the value or the output, right? So it is extracting essentially from the index. And let us also do this thing. Does it support negative values, right? Text underscore data, and then I do minus, right? What is given as the output? It says it is N. So 0 till the end is what we count. So 0 to 36. But if you want to come from this side, this would be -1. R would be -2. O would be -3. C would be -4. The space would be -5. D would be -6. So let us just check that as well. So text underscore data of -6, right? So we get D. That is what we are getting here, right? So whenever we start from the right side, we can do it using the negative indexing. Whenever it is from the left side, we start with 0. So strings indexing for the left side starts from 0. Right side, it starts from -1. Okay, that is what we have. So let's say I want to get just this has, or I want to get Qtcon. So how do I get this Qtcon? 0 is T, 1 is U, sorry. 2 is T, 3 is I, 4 is C, 5 is O, 6 is R, N is 7. So if I do something like this, right? Let me try to do this here. I open the square brackets, write 0, colon. 0 means start index. And until which point we want to extract the data? Until 9. Let's say we do this. So if we do this, we'll also get the space. If I provide only 8, then it will give me Qtcon, right? So that is how we will be able to extract. How many letters are there? 8 letters are there. So if you want to extract 8 letters, it should be 0 to N minus 1. N is the index that we want to extract, right? That is what we are able to do it here, right? So if it was till N, this is 8. So I should have 9 minus 1. which will come as 8. Then we will get this as qtcon. How many we want to extract? That many we have to provide. Right? So that is how we will be able to extract each of these words. Let's say if you want to start from, has, right? So then we can represent this as starting from 9 till 3. So if I do this, we'll get as has, right? From 9, it has to extract, right? So 9 is basically here, the index value of this, and till 12, 9, 10, 11 is what it has to extract. So we are providing 12, or till what value it has to extract plus 1 also you can provide in that. There are multiple ways of looking at what should be the end index. One is to add up and give the higher value, or look at the index value and provide that index value where it is ending. That is also something that we can provide. And just subtract 1 from it. Okay. So that is how we will be able to extract which word is there. So if I want to extract has from this text, I can provide it based on index. Right? That is how we can do this. So we have seen how to move from left side, how to move from right side as well. Left side, we start with index 0. Right side, we start with index -1. That is how we are able to traverse, or we can move from left side of the string value and to the right side. So let's say we want to do using the negative values. So how do we do that? So we can provide something like this. Text underscore data. I would provide -5 to :-1. So it gives us core. So -5 is basically this particular value, and then we have core. So it will give us core. If we want to end, so I can provide something. It will give me core. If we do not want this space, then we can provide -4. Right? It will give me the con letter word out of this sequence of text. Right? So we can use positive indexing or negative indexing. Positive indexing starts from the left. Negative indexing starts from the right. Right? Always remember, this is always the minimum value that we provide before the colon inside the square bracket. It is always the minimum value. Is -4 less or -1 less? -4 is less. Is 9 less or 12 less? 9 is less. It is always the minimum value that we provide. However, positive values start from this end. Negative values start from the right side end. Okay. That is how we will be able to do it. And if we are to look at this, right, what has happened here? Let's say I provided something like this. Text data, 2 colons and -1. We see the reverse of this particular string has happened. N is coming first. R is coming second. So let me copy this and put this here, and let us compare what has happened. Right? This is our text. Right? This is our text. And what did I provide? Text underscore data, square bracket open, and then 2 colons and -1 and the square bracket close. What we got is the reverse of this entire piece of string. So if we do like this, we will get the reverse of the values. We get the reverse of the values. So very simple way of checking whether the word is palindrome or not. We can do something like this. What is a palindrome? Palindrome is something where we have appa. If we reverse this also, it will give us the same word. So data of colon, right? Let me try to print this out. And also print data of -1. Both of them return the same values. Whenever we have data or something where the reverse and the original string is the same, such words or sequences of text are called as palindromes, right? So in order to check if a word or a sequence of text is palindrome, in Python, we can do like this and check if they are palindromes or not. Okay. So this is a palindrome. Right? We have not used any other technique. All that we have used is the operations that could be applied on string and see whether it is a palindrome or not. Palindrome is nothing but if we reverse the strings, it returns the original string. Right? That is what is a palindrome. Okay, so please try to check these executions on your notebook. Take about 2 to 3 minutes from now, and then we will move ahead. All right, everybody done with this? Any questions on this so far? All right, if there are no questions, then we will move ahead. Right, so we have seen how to extract the substring from the string using slicing, right? We have understood that we can also use indexes from the left side and it begins with 0. And if it is from the right side, it begins with -1, correct? That is what we have. So now if you want to reverse it, we have also seen how to reverse it. We use 2 operators and then we use -1. Now, apart from this, what is the use of these 2 operators? Let's say we have something like this. Okay, I say end, and instead of positive values, I give some negative values, I give positive values. Now, what has happened is every alternate word, a letter from this sequence of text has been printed out, right? If I do 3, then every third letter would be printed out. This is like a step value. This is like a step value, right? If this was 0, we got this one. If it was 1 to end, and then we do it, let's say 2, right? Then we would get the other letters, right? We would get something like this: 0, I, O, N, etc. Whatever is given here, right? That is what is printed out, right? So if you want to alternate, we want to get the alternate letters from this particular string value. This is how we will be able to represent it, right? So we have 3 things here within this particular square brackets. One is the start value. The other one is the end value. The other one is basically the step value. We call this as step value. How much it should be increased. And it could be a negative value. That is also something that we have seen previously. If it was -1, right, it uses everything that starts from the end and it reverses the string, correct? That is what we got this as, right? And we also verified this works for a palindrome, right? So this is how we will be able to use slicing within string textual data, correct? That is how we will be able to use string textual data. And this is essentially slicing using indexes when applied on string values in Python, okay? And these are some of the exercises that have been provided. Request you to take a look at them. Text underscore data 0 to 5. What is the output? We get qtick of the qtick as the output from this particular text. Similarly, text underscore data 0 colon till the end. We have not provided any end value, right? It means the end of the string value. So that is why both of them are the same. Either if you write text underscore data in the print statement, or text underscore data, open brackets, 0 colon, no value, and then close the bracket, square brackets, it provides the same output, right? That is what, it doesn't make any difference at all. So we get the values in this fashion, right? Similarly, if you want to get only has from this text data, we can start from 9 and end at 12. This is something that we have seen previously. The same thing has been demonstrated here. You get the has as the output from the original text based on slicing or extracting a particular substring from the string, right? There is one way of looking at it. All right, so the next method or the inbuilt function that could be applied on string values is capitalize. And then we look at count, and then also we'll look at what is ends with. There are multiple other built-in functions, but we'll look at these 3 initially, and then we'll slowly move on to the other functions as well. Let's say we want to capitalize the entire text or the given string. So how do we call this capitalize method or the inbuilt function on a string value? So we have the string value here, qtcon dot capitalize. This is one way of doing it. Either, let's say we want to store this in a variable. I call this variable as word and then put this as qtcon, right? And then we do word dot capitalize. Right? It's the same output. Either we do it that way, directly calling this particular inbuilt function on the string value produces the same output, or we use the string variable and then call the inbuilt function on that using a dot operator. We use the dot operator to call on that particular string value, and then it prints out the output. Now, what does it capitalize? It capitalizes only the first letter or the starting letter of that string. That is what it capitalizes, right? It will give us the capitalized first letter of that particular string value. And we see originally it was in lowercase. Now we get the uppercase value, right? That is what this gives us the output as. Okay, that is what is capitalized. Next function, inbuilt function, is count. So we have count as the inbuilt function. And what do we use this for? We use this for to find out whether a particular string is occurring for a number of times in a given string, right? What does this mean? We want to count how many times a particular string value is available in a string, another string. How do we use this? Or a particular substring is occurring how many times in the bigger string? That is what it means. So let's say we have this particular string that we have constructed originally, right? This qtcon has two words, qt and con, and then I call count, and then we pass this con to it, right? Or I could use this something like this. Text underscore data we have constructed previously. So I use the same text underscore variable and then provide con. So how many times con is occurring in this text? One, and this is the second occurrence. So it is occurring twice in this particular string value. So we get the output as 2. Number of times a particular substring when passed to the count function and called upon the string will return us the number of occurrences that particular string value or the substring value is occurring in the bigger string. That is what it returns. It returns us the number of occurrences that count has taken and is occurring in the bigger string. Here the bigger string is text underscore data. Where is this? We created in this previous cell, right? Previous cells variables are available to the next cells as well, or the subsequent cells also it will be available. If we do not want to use the previous cell and we want to redeclare it, or we want to override it, we can do that as well. We can declare it here and then assign the text value to it. All right. And then we'll be able to use this in this fashion also. Both of them are the same, right? So count gives us the number of times the substring is occurring in the bigger string. That is what it gives us as the output. The next inbuilt function is center, right? Center aligns the string to the center of the double quotes, followed by the additional strings that we are providing. So what does this mean? So the center function is called on this particular string called as qtcon, and we have provided the width as 14. So qtcon's width should be 14. But right now, qtcon width is only 8, correct? So we are saying make the width of the string as 14, and wherever the space is available to the left of the string and to the right of the original string, okay? Left of the original string and the right of the original string, append this hyphen. That is what we are trying to tell this to center. So the length should be 14 and we have to append hyphen. That is what we want to do here. So we get this output in this fashion. Original length was 8. It appends 3 spaces or 3 values here and 3 values to the right side. That is what we have done. Okay. So we have appended this particular value to the left side of the string and to the right side of the string. That is what we have done here. Okay. Let's say we are not providing anything. Let's say I just do this, right? It will append empty spaces to the left side of the string and to the right side of the string, but the total length of this would be 14. How do we know that whether it is 14 or not? Let's say we capture this into a variable, right? I say this is qt word as the variable name, and then I print this out first and print the length of cute word is, right? That way we will know the length of it is is 14. Correct? So that is how we can see what is its length, and it has printed a 14 length cuticon with spaces prefixed and also spaces suffixed, right? That is what we see as the output. Hope this is clear till this point. Any questions till here, guys? Hope you're also running these set of exercises on Google Colab. All right, so let's move ahead. The next inbuilt function is ends with. Okay. So ends with, how do we use ends with? Let us again do the same thing. We have text underscore data, right? That was already built. And we want to know if text underscore data ends with n or some string. So let's see n. And what does it say? It returns something called as true. So true indicates that what we want to check is actually correct. That is what true indicates, right? There are two values that we get, true or false. This is something that we discussed. True and false are Boolean values. If some condition is correct, right, it returns true. If some condition is wrong, it will return false, or the return type is false. So we have text underscore data dot ends with the letter n. If this is the ending, then it should return true. If it is not ending, then it should return false. Let's check with the other case. Let's see if it is S. So it does not end with S. This particular text underscore data. What was text underscore data? Let me try to capture this again. So this is our text underscore data, right? And we want to kind of print that output. So text underscore data is what we have as the string value. And we are checking whether this ends with S. Does it ends with S in the original string? No. And that is what it gives us the output as false. So our check is correct. It does not end with S. So if you want to check a substring is there or not as the ending word or the ending substring in the original string. The original string is text underscore data, and we want to check if this con is available or not. So it gives us as true. So this particular con value is available as the last word within text underscore data, right? So ends with helps us in identifying whether the last letters are available in the original string or not. And what are the last letters that we want to check for is passed in this ends with inbuilt function. That is what it has, or it is taken as the input. Okay, that is how we can check. So the other operator that we can use to check if a particular substring is available or not in a text data, right? Let us use this again, text underscore data. I use this here. We want to check if con is available in this particular text. So we use what is called as the in operator. So con in text underscore data. If it is available, then it should return as true. If it is not available, it should return as false. So con is available in text underscore data. If I say cons, then we get false. Cons is not available. The plural form of con is not available. Cons is not available in text underscore data. If I give con, if it is available in text underscore data, it will give us true value, right? So that is why we can check this again, and we get the false as the value when if a particular string is not available in the original string, right? We want to check if it is available. That is where this in operator will be helpful to compare whether a particular string is available in the original string or not, or a substring is available in the string or not. Right? So this is another way of checking it. One way we only looked at the end. If it is at the end, then we use ends with. But if you want to check the entire string, if it is available or not, then we can find this in this fashion. Con in text data, that is also we have. And we also seen how many times it should occur using count. string.count and then the substring is passed to it, it will give us the number of occurrences a particular substring is available in the string, right? That is also something that we have seen. Right? So another way of looking at this is, let's say we have con can be good during a movie, right? We are watching a movie and then we want to present this, right? We can format this. This is something that we have seen in print, but we can apply this also to the string and then pass it to print. Right? That is also something that we can do. So con can be good during a movie, right? That is where this will be helpful, right? And similarly, for the other way of formatting the string is, let's say we want to find the product of two values. Product of two values. Product of two numbers. And I start with the index 0 and index 1 is index 2. So what does this mean is, this particular string with these indices will be replaced with what is present in the format function. So I say 3, 4, 12. What does this mean is, product of two numbers 3 and 4 is 12. That is what would be the output. Okay, that is what we get as the output. Product of two numbers 3 and 4 is 12 is what is the output that we get. So what has happened in index 0, the first value has taken its position. In index 1, the second value that is there in the format has taken its position. Index 2, whatever is there here, that is what is taken as the position, right? That is what has happened. So if we kind of change this, let's say we do this in another way and we get 4 and 3 is 12. Let's say we change completely, right? Then this becomes absolutely wrong, right? So ordering our indexes within this curly braces, which are also known as placeholders, plays an important role, right? We get the output in this fashion. Hope this is clear. Any questions on this so far? All right, if there are no questions, then we'll move ahead with the next inbuilt function, which is basically find. Okay. Let's say we have our text data, text underscore data, right? Oh, sorry, let me remove this. So we have our text underscore data already. So this is our text underscore data, right? And we want to find where a particular substring is occurring, right? And we want to index where it is occurring, right? So I use something like this, find, and then I provide con to it. Okay. So what has happened here is text underscore data dot find. So find is applied on this text underscore data, and the substring that we want to find within the string is con, right? So this returns as the value as 4, right? So what is 4? 0, 1, 2, 3, and it is starting at 4. That is where it occurs. So it says that where that particular string is available from the left side, right? That is what it occurs. Let's say we want to find from some other starting point. From 9, we want to start and till 36, we want to find if it is available or not, right? So what does it say? From 9, this has gone, right? It is starting from H. And from here till 36, wherever con is available, find it. And at what index it is available. So it says it is available from 32. Now let's say we store this as index start in a variable. Okay. And then I use this again on text underscore data, and I use this number which has been returned. Okay. And put a colon. It gives us con back. So I got this particular value using the find function where con was passed. 9 is the starting index. Ending index till where it should find is the 36 index. It provided us the 32 as the number where it is occurring. So I use this as the starting number, which is 32, until end. It has to find, and it is finding con. So what the find function returned is absolutely right. We can verify like this as well, right? So we have verified multiple things. One is that this particular value returns us 32. And from here, we are also rechecking whether 32 is the starting position for con. So I said in start, because why did I give this end as the end? Because there is nothing else. So I just wanted to check that, and it gives us the con as the output as well, right? Another check that we'll do here is I use text underscore data and say instead of 9 to 36, find, dot find, and the same con instead of 9 to 36, 10 to 25. We are asking the find function, or we are checking from the find function whether con is available starting from the index 10 and ending at the index 25. Is this available or not? And what does it give us? -1. So whenever a particular substring is not available in the original string and we are finding it, and if it returns a -1, it means that it is not available. If it is a positive value, then it means that it is available. If it is a negative value like -1, -1 is only returned. If we get -1, then it means that it is not available. That is how find returns. If it is available, it gives us the index, the starting index. If it is not available, it will give us -1. Fine. So that is how find could be used to find the index of the substring within an original string. That is what find helps us to find. And there are two ways of finding it. One is we found using giving the word in the entire string by just providing the substring like this, or we can provide start index and the end index. So this representation is basically find substring, or let me just put substring, start index and the end index. That is what we are trying to do here. And this one is essentially find and just the substring, right? These are the two ways in which we will be able to find whether the substring is available in the string order. Okay. And also, we also found that if we provide the indices, and if within this indices, if the substring is not available, it will return as a -1 value. Similarly, we can do text underscore data dot find of, let's say, bat. Bat is not anyways there in this string, so it will give us -1 as the value. So any questions still here with respect to find? How we can use it again in order to find whether it is available or not based on the returned index? Any question, guys, with respect to find? All right, if there are no questions, let's move ahead. The next function is alpha. What does this mean? Is that we have a string like this. Let's take a string like this. I call this as words, and I call this as hello world. and I use the inbuilt function is alpha on the words string. And what does this return? It returns as true. What does this mean is every character in this particular string should be an alphabet, or all the characters should be alphabets. And this string should have at least one character. What does this mean is, let's say I give something like this. Words is equals to just empty, no character at all. And I say words dot is alpha. Just give me a minute. I'll print this out. Hello world is alpha. We check this, and this one we'll check again because it is reassigned. Or let us call this words 1 and this as words 2, right? That would be much more helpful in order to differentiate what is words 1 and word 2. And now I say this as no characters here, or 0 characters, right? That is what I would like to write here. 0 characters. 0 characters here. And I write words dot is alpha, and let me try to close this print statement here and here. And let's check this. So when we have 0 characters here, right, it says true. And whenever we have hello world is alpha, this also says as true. Now let's take one more thing. I call this as words 3, and I use now 2, 3, 4. This is also character, okay? And then I call this numbers as characters. Words 3 dot is alpha. Let's execute this. So what do you get here is we get true, true, and false. So whenever our characters are complete of alphabets, we get true. Whenever it is empty, we get true. Whenever it is something other than the alphabets, we get as false. Right? That is what is alpha gives us, whether the string is completely of alphabets or not. That is what we can check for. Okay, that is what is alpha. Fine. Hope everybody has run this. If there are any questions, we may take them up. Otherwise, we'll move on to the next inbuilt function. All right, looks like there are no questions then. We will go to the next inbuilt function, which is called as is decimal. Fine. So let's try to write some numbers now. So I call num1 is equal to 1, 2, 3. This is the string representation. And I call num1, or let me try to do this, print 1, 2, 3 is 1, 2, 3 on is decimal. Right? So we get that. Okay, this should be on is decimal. Give me a minute. Right, we get this value as true, indicating that whatever is there in this particular string, right, is basically all numbers. So each decimals should contains only numbers. It should not contain anything else, only numbers. Let's say if we give something like this, num2 is equals to 23.34, right? That is what we give, but this is a string representation again. So in string, we have this dot, right? Dot is not a number as per string. If it was floating point, it would have been okay, but let's see what this gives us as the output. So 23.34 on is decimal, and then I call num2 dot is decimal, right? And what does it return? This returns as false, right? So whenever we have these kind of other characters which are not translatable and they do not represent a number as such, will be returned as false. So this is not a number. This is not is decimal. Let me try another thing. Num3 is equals to, and then I use this particular encoding representation. This is 00p3. What does it mean is will be clear when we do this. This is actually the superscript, but still this is a number, right? So we call this as, or shall we make this num3? Let me not do this. I'll just print this out in this fashion. U 00p3 on is decimal. And then I call num3 dot is decimal. And what we see is this is a superscript, but this is still a number, right? It is only represented as 3, right? You see this output that is in the superscript format, and it is still a number. So we get a superscript as 3. So on decimal uses false, right? So it is still a number, but this is basically a superscript. So that is how we get the output as when we call is decimal. It should contain only characters, or sorry, only numbers that can be represented as strings. That is what we get as the output. There is another function where it represents the same, but it should contain only numbers, which is also called as is digit. Each is a digit also represents the same thing. So let me try to call this num1 is equals to 34 and num1 on is digit. So num1 dot is digit. Is digit, so something went wrong. Give me. Oh, so I think this should be represented in string. Okay, correct. Right. So we get this as true. So 34, all the characters in this string num1 are digits, and hence we get the output as true. And similarly, let me try to run something like this, A234, and then we call this on num2 on is digit. Num2 dot is digit is what we are calling as, and then we get this value as false, right? We are getting this value as false. So is digit is again the same thing, whether we check the values correctly or not, and whether it represents the number in that format. But then we'll also check what we have done for the superscript, right? It's still a digit, right? So we'll try to check that as well. How does this represent when we try to do this? So call num3 dot is digit. And it gives us true, right? That is the difference between is decimal and is digit. Is digit, even if it is subscript or superscript, will give us the value as true. Is decimal will look only for the numbers that are there in the string, will not look at the other notations. right? It does not encode those values, and it will only identify those values that are exclusively written from 0 to 9 only. It will not look for Unicode values and convert them into digits. But each digits will also look at the conversion and then try to say if it is a digit or not. So all the Unicode representations are represented as digits here. So this gives us true value. Previously, this was false when we used is decimal, right? So that is how we can use this. So these are some things that will be really helpful when for decimals. So if we try to do dot, right, dot will not be a value as such, right? It is only looking for digits. That's all. That will be true. It will not give us false in such. Sorry, it will give us false. It will not give us true in such case, right? Please check that as well. Okay, so only characters that have digits as representations from Unicode representations that will be giving us true. Others would not be written as true values. All right, so next one is let's use the same variable that we had used previously, text data. And this was essentially 2t con has two words, 2t and con. Right now, we want to convert all of this into lowercase, right? So what we can do is we use this and then just do is lower and then it returns us true value. So these kind of functions, essentially when we deal with a lot of text data, and especially when we go for natural language processing in AI and ML, right? These kind of functions will somewhat be helpful when we deal with text data, right? That is where this will be helpful. And also for comparison. Let's say we have two texts and we want to know whether they represent the same sentence, right? When we ignore the capitalization of the letters and we want to know if they represent the same words, then we can do this is lower and then we can check whether they represent the same text or not, right? That is something that will be helpful as well. Okay, this is what we give. This is what we get when we apply is lower on text data. And what we got here is that every letter or every alphabet or every character is in lowercase. That is what we did here or we identified. Let's say if we try to do this on something like this, if we had one or two values that are there in uppercase, right? On and then we say text underscore data underscore 1 is lower, right? And this should return as false. Oops. Okay, so let me try to first print this out and then we can go to that. Lowercase words and whether this was true or not. And similarly, we can have this uppercase included. That is what I'll prove here. Uppercase. Oops, just give me a minute. Included. And then I call text underscore data underscore 1 dot is lower. Right? There are some uppercase letters within this text, and then we want to check if every alphabet is lowercase or not. What happened? It says is lower takes no arguments. What did I pass? Oh, okay. This should be print, right? Yeah. So for one case, we got the value as true. The other case, we got the value as false, right? So all the characters within that string should be of lowercase. Only then this would work. So what I would request you now is to test for is upper. Okay. Just try to use the same thing and see if it is working fine for is upper when we apply is upper. So I use this text underscore data and then I try to find if the is upper is working. Sorry, is upper should be in lower. And then we say is upper, right? So what we get is upper on text data is false. The reason is that not every text is upper, right? But let's say if we have text data where every letter is in uppercase. Was to D and on, and then we say is upper fine now, and then I say for this particular case, right? This particular case is, let me call this one again. Call this one, text underscore data one. So text underscore data underscore one dot is upper. And we get this value as true. So for the first case, we got the value as false. In the second case, we got the value as true, right? So when we apply is upper, it checks whether every letter or every alphabet is in the uppercase or not. Right now, for the first case, text underscore data, this is in lowercase. Text underscore data underscore one, every letter and every alphabet is in the uppercase. And then we get this value as true, right? So any questions till this, folks? Were you please? Okay, take about 2 minutes and then see if you are able to run it on your Google Colab environment, and then we'll move ahead with the next inbuilt function. All right. So if you have done this, let's look at another inbuilt function, which is called a strip. Let's say if a string has something like this, right? Let me call something like this. Word1 is equals to a lot of spaces in there. Okay. And then we have duty call. Spaces, beginning of the word, something like this within the string. And then there are spaces here as well. We want to remove these spaces and just get the word, right? So what we can do is we can call something like this word1 dot strip. Right? It kind of removes all the spaces that are there at the ends. And then we get this particular string like this. If we want to store that again, let's say we want to store this into a same variable. This is allowed in Python as well. So word1 is equals to word1 dot strip. And then we say print of word1. Right? It gives us the same output. Okay. So that is what we will be able to see the output as, where the spaces that are suffixed before this or suffixed and prefixed are removed. They are stripped off. So the next inbuilt function that could be applied is called as title. Okay. So what title does is it capitalizes the first letter of each word in that string, right? So let's say we have something like this. Tuticon has two words, tutti and con. So word2 dot title. What does it do is that every letter in this word, or every first letter in this word, is capitalized. So we have T here capitalized, H is capitalized, T is capitalized, W is capitalized, T is capitalized, A is capitalized, C is capitalized. So every starting letter of the word is capitalized using title. All right. So that is what we do with title. So we will stop here for today, and then we will look at how to capture input from the command line using the input function. So if there are any questions, we may look at them now. If there are no questions, then possibly that's the end of the session for today. All right. Thank you so much, guys. See you tomorrow. Bye-bye. Have a good night.